Welcome back, tech fans. In this video, we're going to be doing part 3 of an ongoing series where I create an LED controller that wirelessly is able to update the color and the on and off state of a bunch of LEDs that you can use anywhere, but I've been designing in order to use a controller for the Underglow in my 350Z, because who wouldn't want a cool integrated light up LED controller, Underglow controller thing in their drift car? It sounds wicked, so that's what I'm doing. If you've not seen either of the videos yet, let me introduce you to what we did in parts 1 and part 2, and you can always go back and watch those videos if you want to catch up. But this is what we have. In part 1, we created this system, which if I power it on, you'll see is a load of bright purple lights, because what we did is take a cheap eBay set of Underglow neon lights, remove the control box that came with it and replace it with this ESP-32 microcontroller. And at the moment, it's a very, very simple package that just boots up and sets the color to purple. That's all it does. And the one thing we were testing is, can we actually work with these lights rather than a proper NeoPixel strip? The answer was yes, we could. In part 2, which was a much bigger episode, we made this, which is a little 1.28 inch screen with a user interface in it that we created using LVGL, where you can turn it on and off. Then you can click the ring and get a selection of colors, and we can change it to say red, and the little drop down back arrow changes to the color, and that shows us that the lights are now red, or they will be, or we can pick any one of these colors. I usually run it in purple, which is why it's my default here. So that's what we have. So we've got this controller and we've got the lights, but right now those two things are completely independent of one another. They don't talk to each other, and that's what we're going to sort in this video using ESP-NOW. If you've never used ESP-NOW, to very briefly sum it up, it's a stateless, persistentless communication standard that allows you to talk one-to-one or one-to-many or many-to-many ESP32 devices. Broadly speaking, it uses Wi-Fi and creates a way of each one of them is constantly listening out for commands that are being sent by the other ones. So in this instance, we'll have our ESP32 connected to the lights, and it's listening, going, has anybody got anything for me? And then every now and again, when we update the color on the controller, it'll send out a code into the ether, say, hey, anybody who's interested in this, this is the new color. And what should happen is the controller connected to the lights listens and goes, okay, I got that, I'm interested in that, breaks the code apart, and then utilizes it to change the color. So that's all we're going to be doing. There is an argument to make it a two-way connection so that the controller with the screen on it actually knows if the lights have successfully updated or not. Maybe we'll do that down the line. For now, we're just going to do like a send and forget. So it'll send the color and it won't worry about it. I'm just going to try and keep it nice and simple for now, and it's a good introduction to ESP-NOW if you've never looked at or used it before. It's one of my favorite ways of making these connection types between devices, especially for a car, because then there's a much less power drain because they're not constantly, listening and connecting to one another. I'm just going to turn off these lights because having a consistent purple glow in my eyes is getting to me. It should be saved for under the car. Before we add any new code, let's just look at what we've got. One big thing to note is I originally created the code for the color controller connected to the lights in the Arduino IDE. I've since stopped using the Arduino IDE and I'm now using VS Code exclusively. So everything was just migrated into here and then used Platformio in order to just do the package management and everything for it. I'm not going to get into that. But if you want this code for for both parts of this device, there is a repo down below, or there'll be 2 repos, and you can grab the code for both of them from that and follow it along. And they are the full setups that you will require for Platformio for these particular boards. So the main CPP file, so the main C++ file for the board connected to the lights, really is dead simple. Just has the NeoPixel library, sets the pin, sets the number of pixels, default colors. It sets what the LED color is. So this is just the loop that goes through all of the LEDs. Sets the pin mode, and then just sends that LED color off. That's all it does at the moment. And the only thing we needed to check and verify that when we were doing this was the standard of the color. So if I sent it RGB, it freaked out because the R, the G, and the B, the red, green, and the blue, were in a different order to what it expected. It was expecting blue, red, green. So we just had to switch that, and now we have proper control of the lights. So that's the one for the LED client. The controller over here is a much bigger file, and this file is where we use the light and versatile graphics library to make that UI you've just seen. I'm not going to break it down here. There's a whole hour and 15-minute video that I finished a couple of days ago about this, so if you want to see how that is made, go and watch that video. What we're going to do today is add ESP-NOW on top of both of these packages and make sure that they are talking to each other properly. The first thing we're going to need to do is make sure we've got the ESP-NOW library available in both of the devices, because otherwise it's not going to be able to find anything. We can just check. I've got a feeling I might have done it already. No, I haven't. Okay. So to make this happen, we need to go to Platformio Home down at the bottom. Then we can go to Libraries. And ESP-NOW, you actually have to use a wrapper. So it's this one, ESP-NOW W. If you tried to find ESP-NOW, it just it's not there, the Expressive plugin, but this one will work perfectly fine. So we can just add to project, select our projects. So we go for the LED controller, add that. Congrats, all done. We'll know it's properly there when we come in here. There we go. So the library dependency has been added for ESP-NOW at version 1.2. And we can do that process again and then add it to the LED client, which I admit I have done already. So there we go. So both of these have now got the code for ESP-NOW available. We're going to start with the simpler one. And in this instance, it is the one that has the lights here, because there's a lot less code that we currently have in it. So it'll be a lot easier to see what's going on. As you can probably expect, we're going to need to include the library. And this one is actually called, as you can see in here, ESP-NOW with a big W. .h. As long as the wiggly lines go away, you know you've probably got it right. Next, we also need to add another one, which is always included because it's base Wi-Fi.h. So we'll include Wi-Fi. And first and foremost, before we do anything, we need to know the MAC addresses of both of the devices, because that's what they use to ensure they're allowed to connect to each other. Without having those MAC addresses, the information gets sent off and nobody listens. And in order to do that, if you Google for ESP how to get a MAC address, you'll find hundreds of examples of the code. For example, this one from Random Nerd Tutorials, and it just shows us we need the ESP Wi-Fi and this read MAC address function, and then we set up the Wi-Fi mode, begin STA, which shows that it's a station. We'll talk about that a bit more in a minute. And then run the read MAC address, and it'll print it out into the serial. So I'm just going to copy this code into my code, and then we should be generally good to go. And pop in the include, the read function. Once we've got this information, we'll just be able to delete the stuff that we don't need to use. Setup. So, and then just run that read MAC address function. Oh, Wi-Fi class is no member STA. Yeah, I think it's just Wi-Fi but begin. Might be an outdated tutorial. Let's just check that and upload it to my board. And with this one, you have to press and hold the boot button in order to connect it. But all being well, when I go to the serial monitor, there we go. There's the MAC address. So we just need to make a note of that. So receiver. And I also want the controller. So I'm just going to copy this code over into this larger one, rerun it, and get the MAC address for that. We don't need to see that all again. Right, so I've done that, and I have my second MAC address. I will be changing these devices before they're put in the car. So if you're ever at the same show as me, you won't be able to hack my system. They will be different. So now that we have these, we need to start setting up initially the receiver. So we're actually going to use a one direction communication standard for now. So one of the components is just going to be a sender. The other one is just going to be a receiver. Good chance that that's what you would do if you were setting up, even one device that listens to lots of devices. There's one receiver and all the others become senders. So that's what we're going to set up here. We've got our MAC addresses. Now we need to set up Wi-Fi, ESP-NOW. It's pretty easy. We don't need ESP Wi-Fi anymore for this. We just go into our setup file, and we had to do this setup as a station and Wi-Fi begin in order to get the MAC address. So we can just leave those in there. So we have the option of setting these up as stations, access points, or station stroke access points, which does both. Really, when you're doing this kind of single direction communication, setting up as a station is fine. If you want to go and dig into the differences between them, you can go and do that. And we don't need that function. So we've got Wi-Fi started up. The code to start up ESP-NOW is, funnily enough, ESP-NOW and init. Now we can just do it like this, but it's probably a good idea to put a small check in there to make sure that this has started up correctly, and if not, pull out a serial log so that we know there's something wrong. So we can just encapsulate that with an if. And if it's not equal to something that is provided with the ESP thing, is ESP OK. So if it's not OK, then we'll just do a serial.print line error starting the ESP-NOW. And we'll just return. Right. So this will start up ESP-NOW and put it into station mode and get it listening. But we need to know, well, what happens when something is sent to us? And we do that. There's two event callbacks that are used as part of the ESP-NOW, basically a send event and a receive event. So we're going to set up the receive event and then the function that runs when we receive information, so we know what to do with that information. Just pulling it straight out of the documentation, the line that you need is this. So ESP-NOW, register the received callback with the type ESP-NOW recover callback. And then this on data received is the name of the function. And then again, if you just pull it out of the documentation, we've got this is the data received, and my data is not right because we haven't called it my data. In fact, we haven't set up that yet, but we'll get there in a second. So this is the data received function. So when information arrives, it goes into this function and is operated on accordingly. But there's obviously an error in here, my data, because of format issues. One of the ways that ESP-NOW ensures that the data that comes through is relevant and correct is that it uses structure typings in order to ensure that the data sent is of the correct structure and that the data received is of the correct structure. So we need to define, we'll do it up here, what the structure of data that we're expecting is. And we're going to have a red, a green, and a blue value, plus a toggle for whether or not the thing is on or off, which I'm actually going to do as an integer, a 1 or a 0, because we did it as an integer 1, 0 when we were building the UI, and it just makes things a little bit easier rather than, type shifting between integers and bools and whatnot with the UI. So we need to set up our structure. So we'll do a type definition of a structure, and that's going to be the message structure. And then we need to just pop this at the end again, just to instantiate it, and then define the things that we're expecting in this structure in the format that they're going to be in. So we've got an integer red, an integer green, integer blue, and an integer, we'll call it power. Now we've got the structure, we need to create an instance of it, and a named instance of it that is actually using that structure. Now here they've called it my data, so let's just use that by doing message structure my data. Simple. So now my data exists and it has that structure, and what this received is doing is going to receive the data as incoming data, and then what it's going to do here is copy all of that into the structure that we've defined, and then we'll have it available as this format, my data dot whatever. So in here, we can now use my data dot red, for example. So we have access to these 4 things in this function: red, green, blue, and power. Right now we've got default colors at the top here, and when we are setting the color, we use this set LED color, which is currently in the loop, not the best way of doing it, and it uses those defaults. We should probably add memory in here, so that as well as using global variables, we use a memory state, so that when the LEDs are unplugged and then plugged back in, it doesn't have to wait for a default command coming from the controller. It just remembers what it was last time it was switched on. We can do that with the preferences package, which is just include prefs or preferences.h. So now we'll have access to preferences. Preferences, like I say, is just a way of being able to write and read from internal memory with ESP2 controllers. Like the Adafruit initialization here, we need to initialize preferences, and I tend to do it just as prefs. So we can access all the functions from preferences with prefs dot whatever, dot get, dot set. And we could probably do with some default values. I'm just going to move these to the top and then set some default values. So an integer for glow red, glow green, glow blue, and integer for glow power. So these, just by putting them as global variables, means I can reuse them throughout the entire application. But when the application loads for the first time, I want it to check memory, see if they've been stored, and if so, put the lights on in that color. We do that by going down to our setup, and we have initialize the buttons, pin mode, LED.begin. So after LED.begin, we'll get those 3 colors. So start with glow red, and we'll set it to prefs, which is our memory allocation, get the integer value, and then we'll call it glow red. So that's the name of what it's going to be in memory. I just thought I need to actually initialize prefs, which we do with prefs.begin, and then call it the name of the application, so glow app. And then we need to stick false at the end, which makes it read writable. Otherwise, we'd only be able to read from it. It would stop us overwriting anything. So now prefs is started. We read glow red from the glow app. But if that integer doesn't exist at that memory location with that name, we're going to just use default red like that. And default red is defined, I think, to 140 because I like purple on my underglow. So 140.0255. Yeah, so 140.0255 default red. And we can do the same with the others. So actually do a 4. Glow red, glow green, glow blue, and glow power. Default red, default green, default blue. I should add the default power at the top. I haven't got that. So glow red, green, blue, and glow power. And then I just need to set the default power. And we'll say that it defaults to on. Groovy. So then we need to set the color. And I'm going to think about the color and the power sort of separately. We'll do this set LED color. Because I've made these colors global variables, I don't need to pass anything into it because these will now be stored with the global variables. So when I use my set LED color function here, I don't want to pass it the color anymore. So instead, we're just going to use the global values. So glow red, glow green, and glow blue. And then LED.show basically sends all of the new data to the lights, but we only want to do that if the lights are on. So we can just do an if around here and check the state of glow power. So if glow power is equal to 1, then show. Otherwise, we'll clear, which is just LED.clear. And that effectively switches all of the pixels off. Now, if I remember correctly, these LED lights don't understand clear properly. So this is how you would do it if you had a NeoPixel strip. But if we do a clear, I've got a feeling they're just going to be white. So I think I have to set them as 0. So that won't work. But instead, what we can do is surround this set pixel here. Otherwise, so if the power is set to off, we're just going to set this pin to 0, which is effectively the same as off. And I think that works for these lights. Usually you would do it the other way and just use the clear. Oh, we do need to keep the LED.show though, because we need to then send that new information to the LEDs. We're actually almost there. So we've got this function now that will set the LED colors based on the global variables. All we need to do is when a request comes in from the other device that's sending over the data, it needs to set those global variables and the memory variables based on whatever's been sent in. And we've got access to all that here, so it's going to be really easy. We're just going to do glow red is equal to the data that's been sent red, glow green, glow blue, you get the idea, and glow power, which will set the global variables. And then we need to update the memory variables. So prefs.setInt. Was it put int? Yeah, put int. And we called the first one glow red. So we're going to store glow red. So we can set that with the global variable. And again, 4 times over. And unless I've messed something up, that should be everything that I need. I'll just reduce that debounce. I believe that's everything. And I think actually when you're in the receiver, you don't need to set up the controller MAC address. You only do that when you're sending. Yeah, that's right. So we're not going to worry about that right this second. I might be wrong there and have to come back to that. But yeah, so we set up our defaults. We initialized the lights. We initialized the memory state. We set some global variables for our 4 values. We set the structure based on those 4 values and create an instance of that structure. Then we've got the actual function that sets the LED color. So it goes through all of the pixels one at a time. And if the glow power, if it's switched on, sets those colors. Otherwise, it sets everything to 0 and sends all that from memory out to the lights. And we've got our ESP-NOW received function, which takes the incoming data, copies it to this internal memory based on the structure. I mean, technically, you could forego doing that entirely and just use mydata.red, green and blue in here, but this way is, I think, a little bit nicer. Then we have set the values to the new red, green, and blue of the red, green, and blues passed through, as well as the power. Then we save those things to memory, and then in the setup, we initialize the Wi-Fi mode, we initialize Wi-Fi, we initialize ESP-NOW, we register the callback, and we set up the values of the variables, the global variables from whatever is currently in the memory state, and then we set the LED color. That should all be good. Now this is set up for the wrong environment here. So I just need to switch to the LED client, which is on a different port. It's on port 3. And then I'll just upload that. And that should be the receiver done and out of the way. It's the easier of the two. The other one actually isn't really any harder. It's just that there's a lot more code that we wrote for it. So I just need to find the right spots to put it. But it's probably even quicker than doing this because we can probably copy and paste a good deal of this into the new one. No problems with that upload. And if I switch the power back on, we have white currently, which actually kind of makes sense. No, there we go. There is a quirk here with the power setup. This little power thing that I'm using that splits out into 12, 5, and 3 volts. The 3 and the 5 actually put out much lower voltages than they're supposed to. 5 is running at about 3.5 and 3.3 is running about 2. So they're not providing sufficient power to the ESP in order to make it actually run. It'll be a thing that we get past when we do the next part and we design the PCBs for this. But yeah, I just need to have that plugged in so that it has a common ground, which these lights require. They need a common ground with the power supply, but it also needs to be plugged in. It's just a bit of a pain. So let's move on to the other controller. And this is this bit is the sender. So we're going to put the other bit into here that runs off this other controller. So I can just switch this over to the controller default for the controller. Let's start bringing some code over then. So if we start at the top, we'll need Wi-Fi and ESP-NOW and pop them in. Good time to just save, and then your platform, will go and download any dependencies it needs in the background and put them all into the right spot. We're going to need this MAC address in a moment, but first let's just define this message structure and create an instance of it called mydata, exactly the same. So we'll just define this one at the top. So there's my message structure brought in. So this one does require some stuff that the previous one didn't have. For example, we need to set up the broadcast address, so the MAC address of the thing we're sending to. So we do that as it's a unsigned integer, and it's an 8. Ooh. We can call it client address, and then the MAC address we just need to get from the receiver here. We need to change this to the OX format, so OX, and swap the colons out for commas. So that's our broadcast MAC address set up. The other requirement we need to set up that is pulled straight out of the library is the peer information, which is what this client address uses to initialize the peers and say, this is the device I want to connect to. So we define it with the type ESP-NOW peer information type, and we'll call that peer info. So then we've got an instance of peer info saved as peer info. Then we can take a bunch of the stuff out this setup file again. So Wi-Fi mode is going to be a station, Wi-Fi begin, ESP-NOW initialization, and then the callback, though the callback we're going to change. We can take all that and just come down into the setup file. So we'll set that all up after we've done the load of the home screen. So that'll initialize everything, but now we've got this data received function. We're not going to use that callback because we're not receiving anything with the controller. We're just blind sending stuff. If we get to a point where we're sending and then listening for a specific response, we will use both the send and the receive callback. But right now, we're only going to use the send callback. We don't need to give it a type. We can just give it a name of the function that is the callback function. And it has to be, you have to have a capital first letter. Just one of the many quirks of ESP-NOW. So on data sent. And then we can set up that on data sent, which again, you'll probably just pull this code straight out of the documentation, but it's this on data sent from the MAC address and what was the status of it. And if the status is successful, then do one thing, otherwise do another. The bit we're missing here is the information that we use with this peer setup. So the fact that we've set up this peer and this client address. Again, it's code you just pull straight out of the documentation. Bam. And not broadcast address. We called it client address. So this is going to copy that client address to the peer information, which is pulled out of ESP-NOW, and makes that peer address, and it's a 6-parter because it's a MAC address, it's in 6 parts. We set the channel as 0, and we're not doing anything encrypted. So we're just setting up peer info with the information that we've ascertained. Then we're going to add a peer using this ESP add peer. And if it is not okay, it failed to add. Otherwise, it's all done and the peer is added. The only thing that is going to be left to do is basically define the contents of my data. And then on the instance that anything updates, so if the power updates or the color updates, send that state of that my data structure off to the attached device. If we start in the place where the color is set, so we have the click event for the color buttons. Where are you? Color click event. Here we go. So this has actually it in a different format here, which we then extract out. That's fine. what we need to do is below all of this, set these values into my data. So my data dot red is equal to glow red. Is equal to glow green. Blue. And because it expects it, we might as well get the current state of power. And there's a global variable here for power state. So I'll just take that global variable, which will have the latest instance in it of whatever power state currently is. And then there's a bit of code we want, which is this little thing that goes to client address. So this is defining our type of a result. So we're going to look for a result. We're going to do the send. So this ESP-NOW send is saying send off my data to the client from the client address that we set up in the peers. And then it just has a check that creates the size of that. So then it can do some verification stuff back and forth to make sure that the size received and the actual data that comes through are the same. So we can do a little check with this, which is result, because we've just defined this result is equal to, if you remember, ESP-OK. So that's if it's an OK connection, then serial.print sent successfully. Otherwise, error sending. So that's basically most of the way there. I'm just going to copy these and go into where I do the power button code and click the power button. So power click event here. So let's paste all that below and change this. So these run off the global variables still, which is fine. This power state needs to now be updated. So we can just set power state, which is actually a global variable that we defined. Power state here is equal to 1. Otherwise, for some reason, my tab is now not working. Power state is equal to 0. And then again, bundle all that information together and send it on. So because we've reused this exact same bit of code here twice, we should probably do it as a function. So send ESP data. Because as long as the global values and the power state are all done properly, there's no need to do this twice. So that's just a send. So that's send ESP data. And then I'll just replace where I wrote it down here. And all being well, that's it. This is going to be interesting to see if this works. There's bound to be something I've forgotten. Okay, so let's upload this to the correct port. See what I've forgotten. There's bound to be something. Getting this right out of the box first time would be miraculous. Is it still going to come up with a screen when it finishes uploading? That's the question. Right, okay, we still have a screen. I have, like I said, this is a little bit of a pain in a minute. I have more confidence in the color changer. No, I shouldn't have had. So it's not doing anything. So what does the serial monitor say? Let's reboot this. See what the serial monitor says. Oh, there we go. Delivery fail. So sent successfully. Delivery fail. So okay, so but you can see that when I click on each one of these, it does try and do the send, even though it's not actually delivering it. So it could be one of a few things. Could be as simple as the fact that I haven't set up the MAC address quite properly there. Let's try that again. I'm still getting that delivery failure. I just need to run through this and debug it. I'll be back in a minute with the solution. All right. Turns out it was working. I just hadn't set, in this data received, I hadn't done the set LED color functions. So it was updating all of the variables in the global and putting the new values into memory, but it wasn't updating. So you might be able to tell from this nice ambient red glow on the side of the face, this is what we've now got. Here's the controller. Off, on. And then we do this, go to yellow or green or blue, and white and red. And you see it's basically instant. And we go back, purple, off, on. And like I said, this is all completely wireless, completely stateless. So if I unplug this, then plug it back in again, it still works fine. So if I, turn this off, and it's now off, and I unplug this and plug it back in, this is still off. Similarly, if this is turned off and turned back on, it's still off, and then you can turn it on. And the same, the memory of the color should persist as well. So if we go to red, turn it off, turn it on, it's still red. So everything, works, and it's stated in between the two. Lovely. So as you can see, using ESP-NOW is actually a pretty simple way of doing this wireless data transfer stuff. You set up what happens when something gets sent. You set up what happens when it gets received. You just have to set up the IDs of the clients for what you're sending information from and to. And then, it goes from there. You can obviously, if you wanted to expand it out, this controller that gets the client address, so basically the address of the station that receives all the information, you could use that for multiple things. And we will be doing an instance of this in a future thing where we take things from around the car like speed and tire pressure and a bunch of different stuff and bring them together onto one central display console. And that'll use this, and basically lots of different things can just send their information to that one central controller, and it just sorts through it and, utilizes the data in the way it wants. But that's a look at using ESP-NOW to control your lights. So what I need to do, next step, I was going to do it in this video, but in hindsight, it's going to take too long of a video. And let's do the separation of concerns. Let's do an extra video, a little Brucey bonus. Next thing I need to do for this and for the actual other thing, I need to create a PCB, which then can have the proper power management, because there's some power step up, step down, common ground issues going on over here, which is causing problems. So I need to create a proper PCB to make sure that when it's put into the car, it's safe, it's secure, it's not going to have any voltage issues, all that kind of stuff. So we'll do a new video. So I'm going to release this one in the next day, and then in the next couple of days. So whenever you're watching this, chances are it's going to be no more than 2 more days, and we'll do one about creating those PCBs and what you need to do for component design, considering step up, step down voltages, all that kind of stuff when putting these things into a car. Then there'll be a final video where we actually take this, create the 3D printed enclosure and everything for it, because I'm going to have to wait a couple of weeks for the PCB to come. So, you know, might as well do something in the meantime. And we'll do a little video about then taking all this and actually installing it in the car, and you'll be able to see it up and running in its proper environment. And that'll be awesome, because actually seeing this in the car is going to be really cool. There we go. One other successful video. Hopefully now you see why I was doing this and why that's pretty cool, and why we used ESP-NOW for it. That was really simple to get that wireless connection set up between those two things, bar one obviously small error. And if you want all this code, it'll be up on a repo, 2 repos in fact, one for the controller and one for the receiver. The links will be in the comments if you want to grab those from my GitHub. But yeah, what do you think of this? You like it as a solution? I think it's pretty neat. Be interested to hear what you think. Anyway, whatever you do with the rest of your day, folks, have a wicked one, and I'll see you in that next video where we're going to get even closer to actually getting this thing finished. Take it easy, peeps. Bye now.